Welcome to Horizons, OS Global's Thought Leadership podcast, where we'll be exploring the evolving worlds of engineering and careers in technology. And I am Sridipta Das. I'll be the host for this session. I've been around in the industry for close to 3 decades. And I'm always at awe whenever I look back and I think about the amazing transformations that the world has gone through in the last 2 decades, since 90s, since we all have started our careers. And especially how semiconductors and electronics have touched almost everybody in the world, and how it has made the world more livable, safer, wiser. And today we'll be talking about careers in semiconductors, because for any industry to thrive, you need young talent to be inducted on a regular basis. And especially now when we are at the cusp where some new technology is emerging on a regular basis, new startups are coming up. And more importantly, I think India is gearing up for a new phase where the semiconductor production and the ecosystem would be at par with the rest of the world. So what we'll be doing, we'll be talking about some practical tips and some advices for the aspiring engineers. And we'll talk about the trends, we'll talk about the skills needed. And for our viewers, we have 2 amazing personalities today, 2 industry stalwarts, and more importantly, actually 2 people I have been associated with and I've been proud to know them in my life. So I will introduce Naveen Bishnoi, who is the country head and who heads the engineering operations for Marvell India, and Sumita Limaya, who is heading the semiconductor vertical for OS Global. Welcome, both of you. So Naveen, I will start with you. Mm-hmm. So, all of us, we started careers in 90s, which was again another cusp. And just to, put the things in perspective, the last 200 years of the modern era of industrialization has seen roughly 5 such cusps where things have moved or changed in a amazing tectonic fashion. First, say with the steam engine, which happened middle 19th century. Then the electricity and wireless around the end of 19th century. Then electronics or semiconductor, which came around the Second World War. And then we got the telecom and internet. That was another cusp where we started our career. And again, roughly after 50 years, right? We are seeing another tectonic shift in the industry, which is AI. So I would like to, talk to our viewers about your journey through this, through the last 30 years, where you have also seen the 2 tectonic shifts. And I would like you to also, touch base on how you have evolved from being an individual contributor in the 90s to a leader now. Over to Naveen.
Sure. Thank you, Sudipta. Pleasure to be here, and I'm especially honored to be here with Sumedha, who has ensured or mentored what I am today. Growing up in Bhilai, in central of India, Chhattisgarh in 90s, which is the steel city, if you were relating to the industrial these things, I've seen that it was always, I was always in the middle of the engineering mindsets, right? That was the mindset about saying, grow up to become an engineer and solve bigger problems. It was all factories of those steel plants and others. And that's what enabled me to come into a field where I came to Suratkal to did my engineering, and electronics was the choice to ensure that that was the upcoming field to make the world better. TI happened as the first job for me in the 90s, right out of campus. And at that time, VLSI was not something that was famously known. It was more electronics, and then you end up being in VLSI. And I happened in TI. Started with an individual contributor. So I've seen from the days of doing the EDA tool development inside, move on to build the flows and methodology, and then end up doing an end-to-end design to enable the chips of the world that we see today, right? And the career has been from every time I thought that I will become an engineer, I can do something, there was always someone who told or who kind of reflected that, hey, I can do more. And then that's when I've started figuring out, yes, I can go to the next level. I can go do more things. And doing things, all of those right here from India, has been the background for having those mentors, the opportunities, and then being able to do the next level to drive it into the place where now I lead the whole Marvel India operations, driving everything from the technology, IP, and design, software, validation, system, and then finally the customer enablement. So it's been a good journey to be able to see everything end to end and then be able to contribute as part of the ecosystem.
Okay. Almost a similar question to you, Sumedha. So why don't you also talk about your journey, and you can also highlight, the technical and the non-technical soft skills which you think might be relevant and also important for the fresh grads.
So maybe I'll walk through my journey and then I'll add a little bit of advice to engineers. My journey very similar to Naveen. I too grew up in Gwalior, which is a city in Madhya Pradesh, a relatively small city. And I come from a family of academicians, teachers, and engineers. So a lot of math and science emphasis in the family. So for me, becoming an engineer was a default. I had to rebel to not become one. It was like that. I would say, very happy childhood I've had. And at the end of it, I got into University of Roorkee and I got into electronics and communications, right? So that was a turning point for me. Of course, Roorkee was a really amalgamation of people coming from different parts of the country, lots of learning, lots of exposure. At the end of it, almost everyone was doing, trying to learn software and get into software companies. I wasn't really taken up by that. And I happened to appear for a kind of a CMOS-based entrance by CMC, which was a public sector company. I was the only one to get through that. And that is how I landed up into VLSI. And it was really lucky that I could really stay a hardware engineer. And after that, from CMC, I moved to ST. This was the era when we were moving from public sectors. The economy had just opened up and MLCs were entering the country. Stayed in Delhi for maybe less than a year and then came to Bangalore, joined Texas Instruments. And really, the foundational part of my career, the first 20 years were spent in TI. Naveen and I worked there together and had some really good learning. So in TI, I did everything from circuits to CAD software, where we were in the same team. We moved to actually work with EDA vendors and move from in-house software to EDA-led software. After that, I was managing IP design for Romap, then moved on to do SoCs and microcontrollers. And that really built the foundation from circuits to systems and allowed me to take up a server SoC kind of a role at Intel. And Intel, I spent about 10 years doing servers and edge servers, networking servers, etc. So I'm very thankful for the journey. A little bit of advice I would say is you start your career journey with an open mind. Be very curious and really adapt and move with whatever life throws at you.
Okay. So it's interesting that you both had worked in TI for a long time, and I think TI plays a very big role in India because it's one of the earliest companies which came to India in VLSI. And a lot of people might not know that the foundation of TI in India goes back to Rajiv Gandhi's time when he opened up telecom, right? So in fact, TI symbolizes this cusp from the pre-telecom, pre-internet era to the later internet era, right? So okay, nice answers. So the next question to Naveen.
Mm-hmm.
We have been seeing again a lot of changes since 2020, right? So would you like to talk about some of the changes that you see in the industry and how would that impact the next generation of people who would be joining us, who would be joining this industry?
Sure. Yep. I think the last 5 years, primarily, I would say 2020 still we relate to COVID, right? The pre-COVID and the post-COVID. So for sure, one of the biggest change or a phenomena that we realized is that how do we work across the borders in a time like COVID? And that's where a lot of agility, the global collaboration, and many of those things became so-called as right in front of us, and we adopted and made ourselves. So instead of earlier where the talent used to move to where the jobs are or the companies are or the innovation is, we started seeing that the jobs and the companies and innovation started moving where the talent is, right? So that's a good sign that's happening. And it's, I think, expanding the globalization that we are seeing right now. The second part I would say is that we also saw from 2020, and this thing is this whole AI buzzword that came in, right? So while we were doing a lot of developments, we were talking about internets, the mobiles, the automotive, IoTs, all these buzzwords, we heard it. And then came AI. And that kind of changed the pace at which innovation was happening. I think it was, again, another technology, but the pace was super fast. Thankfully for us, I still relate to it, saying like, hey, we are the building block for the AI. So VLSI for AI. But then we also started acknowledging, how do I use AI for VLSI?
So AI for VLSI.
VLSI, right? So I think those are the two trends that I'm seeing, is that how do we work in a big global environment, as well as how do we leverage AI for chips while we build the foundation for the AI.
Oh, so I think one of the takeaway from your answer is that, since 2020, it's both AI for VLSI and VLSI for AI. Right? Sorry. And another related question, right? So you are also the vice chair of ISA, which is India Electronics and Semiconductor Association. Yes. So as a part of that, right? What would you say to the young engineers, right, who might be looking at the career either in semiconductor design or semiconductor production also, right, which in India is now becoming much talked about things, right? So
true.
So what are your thoughts?
Yeah, I think that's what excites me and why I play that role, right? That's the third part of post 2020, that the COVID also enabled a supply chain disruption.
Exactly.
And that's where most countries started coming together to say that, how do I create a self-reliance? Not to become disconnected from the rest of the world, but at least be self-reliant and can do all of that. And that's where you saw there's a lot of focus in the semiconductor ecosystem in India to create the complete ecosystem, which is not just design, which was heavy for India for so long, but also get into the manufacturing, supply chain, and end-to-end, and finally ending up into a product or a system, right? And creating that ecosystem, everyone needs to come together. We need the government to bring the policies, which we are seeing pretty good in the last decade. We needed academia to build not just the talent for the world, but also to build the innovation, which can build into an IP and that can get into the final product. And we also needed the industry to come back and work with them so that we can also make some products for the India, from India, for the world. And to tie all of those things together, we have this body called ISA, which is the association to bring all these together and discuss what are the policy needs, what are the products that we need to make for the India, what are the production capabilities that we need to do, and underlying all of this will be the talent ecosystem that we have to build the IP and the product. And that's what we are focusing from ISA, to connect these dots, serve this all three vertical, and continue this ecosystem growth for India.
So Naveen talked about self-reliance, right? And our Prime Minister keeps on harping on this thing, like Atmanirbhar Bharat, right? Which is self-reliant India, right? So, talking about self-reliance, I think startups play a very big role in this, right? So, so the government has promoted a lot of, schemes for startups, right? Now, a very pertinent question, right? Between startup and an established company, right? People always have this dilemma. Like I will share one anecdote, right? When I first went to Bay Area in 98, some of my friends were doing grad in Stanford, and they used to talk about a guy, a very nerdy geek, right? Like who was working on something called Backrub, which was which they told that actually would revolutionize the search engines, right? I left US in that trip in August 1998, and in September, Google was formed, right? Okay. So, so Larry Page and Sergey Brin were geeks. They started the startup, and which now has become a big company. Like every big company was a startup, of course, right? So, there is this classic like philosophical dilemma about creation and sustenance, right? A startup is a creator, but you cannot have the same mentality after the company grows, right? So, could you share your viewpoints about what should people think about, choosing a startup versus an established company?
Sure. So my advice, and this includes my daughter, my elder one, I told her when she finished her master's that she should really join a smaller company because there's a lot of learning into it. See, the kind of students who want to create startups on their own, even if you advise them not to do it, they will still do it. The founders have that hunger. They don't need anyone's advice, right? So I have nobody to advise, that. I think you're talking about the middle band where they're talking about whether to get employment.
Yes, employment startup versus
employment in established companies. And I would say from a learning standpoint, because again, going back to what I was talking about, my own experience as a career journey, it's very important to build the foundation, right? And that means you should be in a place where you get to learn, when you get the chance to understand what you are doing, in a reasonable amount of end-to-end fashion, and not be limited to a very small, super specialized skill that you have to do repetitively. I think that's really not the right thing to do. So invariably startups, and especially the ones which have been around a little bit and have the kind of systems to support a fresh engineer, right? Where at least the problem statement is clear and you are supposed to be working on solutions to that problem. I think that is the ideal place to join because there's no bureaucracy. There is no one stopping you from doing what you want to do. And they actually want you to think differently and solve problems, right? So that is the ideal place for fresh graduates to join. And even if the startup fails, really there is no impact on a fresh graduate's career, because the next company will look for what you have learned through that experience. Nobody really cares whether the company itself did well or not, right? So from a learning standpoint, I think startups and mid-sized companies are very good. Also, you have these innovation labs in large companies. You have smaller startup-like environments, even in large companies, where you can actually join and do very well, right? So you just have to be smart enough to find the right place where your creativity is required and join that. So like I was saying, even in large companies, there are these innovation labs. There are smaller startup kind of groups who are trying to do new product development. It's a very good idea to look for those as well.
Yeah.
Right?
And then we saw that in wireless or the OMAP decision that got created.
Yes.
I think the people, what they learned there probably are the most versatile or the most learned people there.
Absolutely. That's a great example. Yeah.
I think you brought up a very nice point, right? That even if the startup fails, right, the learning that the person would have done in the startup would actually sustain. And here I remember one of those famous quotes by Andy Grove, right? That every employee owns his or her own employability.
Yes.
So whether a person would be employed is not a function of where he worked, but what he has done and how he has done. That's right. So from that point of view also, right? So coming back to this employability, so actually this is related to skills, right? What skills person would have inculcated. So the question to both of you, right? Among like say the design, verification, embedded software and packaging and other things, right? Which are the major skills or new skills that you see would be more dominant like in the next few years? I think Naveen, you can go first.
Okay, I can build on it since you said two. I will pick up from like when we were starting, at least many decades back. I think
In the 90s.
we were kind of limited by saying, first of all, is it software versus hardware?
Exactly.
Then you come in hardware, front end versus back end. Then in front end or back end, somebody is doing only design or only verification or only DFT and XYZ, right? I think that lines is blurring out if you see, right?
Exactly.
To make a chip or a product that will work first time, you need a much broader set of knowledge, right? So two skills that if I have to bring up, verification is becoming much and much more important to make the chips, which is for AI, which means in the latest technology node, these are huge chips. They integrate a lot of functionality and pieces from processor to memory to IO and everything else. You need to do it first time right.
Absolutely.
And our percentage, if you go and check, that first time right metrics is significantly down. And we spend $100 million for each of these product development. And imagine if you can do a verification much better so that it ends up being first time right. So verification, and it's not just the traditional functional verification, the verification that you do, which is embedded in the design, the verification that you do at IP versus subsystems versus chip, what you can do pre-silicon versus post-silicon. A lot of focus of verification becomes much more important from that perspective. The second one I'll bring in more from an India ecosystem for us to go up further into the value chain. We have done everything in a product life cycle. I think what we are pending is that who creates the specs and maps into architecture, right? So that is the next one, is that how do we create a use case or an idea into something that can become an specs, and then we have millions of engineers who can convert that specs into a GDS and into a rectangular form factor in our hand.
Yeah, maybe I'll just add to that, right? So I'm kind of expanding on that theme of being broad and being kind of a system engineering kind of a mindset. Now, it may be very daunting, for a new graduate coming out of a college to think, how do I suddenly look at the big picture? I think one very small way to kind of inculcate that is what they used to teach us as TI, at TI, that whatever task you do, you understand the inputs and outputs of your work. That's it, right? You understand what inputs you are getting, what do they really mean in a context-independent way. One way to look at it is, can you explain your job in a job interview, where the interviewer does not know any terminology, any company internal terminology, you are still able to explain it, right? So to that extent, you can start having that mindset of understanding end-to-end your task. And then as you go through your career, you build on it and you develop this system level understanding. In fact, maybe I'll add a little bit. Last week we were in offsite and we were discussing these themes of how AI is impacting jobs, things like that. And one of the things that actually Rob Batter brought in was this concept of a polymath engineer. So he was talking about the fact that now that AI is taking up all those small, repetitive, super specialized jobs, the engineer's job really becomes about identifying the right problem, defining it in the right way, and then bringing all the pieces together to solve that problem. Because the world still has many, many problems to be solved, right? The need for engineers has not gone down. But the way we have looked at fresh graduates doing small, little repetitive jobs, I think that will no longer be required or be valuable. And in fact, it's a boon in disguise because you can do true engineering and you're really applying your brain for creativity, for framing the problem and solving it, which is really what engineering profession is all about, right?
So, talking about this polymath engineering, right? I read somewhere that thanks to AI and also this like humongous amount of computation that people do now, right? They have actually, mapped the various parts of the brain and also the various neurons, right? I mean, which are triggered by different activities, right? And they have figured out that whenever multiple neurons which are supposedly activated for unrelated actions are fired together, that creates actually more decision. It helps in decision making. So this very fact that Rob was talking about polymath engineering, right? It also has a neurological side to it. So it's a neurologically approved.
Interesting.
Okay. I think next question is again to you, and it is again related to the freshers you're talking about, right?
Yeah.
So you have answered a part of the question, right? So what should a fresher look forward to in this new AI realm?
Yeah. I mean, I kind of answered it, but really I'll keep it a little crisp, right? I think the requirement is for an engineer to be able to think broader and to be able to look at the big picture, to be able to identify what the new problem that we are trying to solve actually is, right? So if you look at AI is really based on identifying patterns from the past. And it is true that a large part of what we do on a day-to-day basis is a repeat of the past in some sense, right? And that perhaps AI can do better because it can assimilate data and find patterns much better than a human brain can, right? But whenever it comes to identifying new problems or new problem definitions, AI cannot do that. Anything to do with creativity, AI cannot do. And also, I have a lot of faith in this innate curiosity that human beings possess, which keeps them, propelling them in forward directions, right? So really coming from mind frame, I would say for new engineers, instead of having, I think the term is FOBO, fear of being obsolete, instead of being scared about AI, how do you actually use AI as an aid to kind of do repetitive stuff faster, and then you focus on the creative part of the problem is one advice that I would give. The rest of the advice, I think, it stays unchanged in terms of how you approach your job, in terms of work ethics, etc. I'll not repeat that. But this thing about how you treat AI as you enter the workforce, I think it's very clear.
Okay. So now that we are on this, freshers topic, right? Another very related question, right? What are your views about internship or early activities during college, and how does it help? I mean, I see now people are filing patents, right? In ITs, right? They have patent lawyers, where I heard people have been filing patents in first year and in second year, right? How are these helping or not helping the ecosystem? Your thoughts on that?
Internship is something that has come as I would say, very strong stepping stone, or a transition from what we called as an academia or a campus to a corporate one, right? Most of us run a huge mentoring internship and accordingly mentoring comes in program, where first thing first, this is the new generation. Not just we want to decide who works for us, whether they have the right skills. Many of them decide whether they want to work for us or not. So giving them exposure to our office, the kind of people, the kind of technology, the kind of tools and other things, and culture is very important part of getting your talent on board and ensure you can continue with that growth and development that you're planning. Second thing is that our academia was traditionally being very theoretical, bring in the foundations and theory. The hands-on has significantly come to a very large extent into the academia. They have access to all the tools, all the technologies and everything else, but still come to the real world and validating those learning with what's happening in a real world problem solving is what internship provides. And that's a very good platform. The third one is that when you are in the middle of hundreds and thousands of engineers and the corporate people and the functions, you get to learn on many different things that you probably do not learn in a regular engineering course, whether it is about the power of collaboration, whether it's a power of documentation, building the whole network of mentoring. I have one of my mentors sitting here. She told me,
My mentor,
right? She was my second manager in my career, and I still remember that she told me when I was leaving TI to go to Noida, and she told me that, Naveen, whatever you build a career, please ensure leadership and management is part of it. I don't know what she saw me. I always feel very proud that I could feel prove her right by continuing in that path and have leveraged that and then built on that as my strength. And then contributed to this. So I think a lot of these is through the internships and especially mentoring and this exposure is helping these students to be much more faster, I would say, relevant and contributing to the growth that we are.
Actually, I mean, Naveen, that reminds me, adding to that, I heard from Dr. Satya Gupta, and maybe you'll know more about it since you're part of IESA. There's this program called One Tops.
Yes.
One tape out per student. That's kind of the vision that every engineering student that we have space should be involved in one tape out. The kind of things you talked about, collaboration, teamwork, problem solving together, being exposed to a work kind of an environment. I think that is something that our education system has to catch up. And that's really the focus.
Okay.
Yeah.
So again, from freshers, we have now come to talent and sort of teams, right? So the next question to you: how do you identify a dream team? I mean, what are the parameters, or or is there anything called dream team? Which you can find?
Yeah, I had. I was fortunate enough. In fact, Naveen was part of the dream team we had, and it was a fabulous team. And I'll kind of list on some of the components. The first and foremost, which is perhaps sometimes not there right in the beginning, but you have to hunt for it, is you do need to identify a product or, a service offering or something that brings the team together. Because invariably a team is made up of diverse people. They have their own aspirations, their own ways of working. You need something that binds people together, right? And it should be a product or a service offering or something that the value that you are creating for the world. Because if you just create a team of individuals who are working on different things and they are just meeting over tea or coffee, I wouldn't call that a real team. Of course they can be friends, but that's not what we are talking about here. So something that binds them together, brings them together is essential. The tenets by which you do things. So it's not about just what you do. So you do define the what, but then how you do it. What's the culture? What kind of values? Having an open environment that is free of fear, where people can express themselves is essential, and that they put the team first above their individual interests is important for the team to come together. And then of course have fun together. It's important for teams to be bonding over time that they spend outside the work as well. And we were fortunate, Naveen, if you remember, we still meet. We've not been in the same team for more than 20 years now, but believe it or not, we still meet quarterly and have so we had people like Naveen who really kept the team spirit alive even till date we meet. So I think that creates a real team, and the test of a team is in what it is able to deliver. So all the great teams that I have had, and I had a really good team in Intel, I'm sure the team we have in Quest India, we'll go and do huge things together, right? The test lies in what you actually deliver, what is of value, what kind of product, what kind of service, and you take the level of things a notch above, right? So my metric for myself is that everyone who joins the team, they should be able to say with pride that in this team I learned and I could take my career a notch upwards by being in this team, right?
So you, as a passing thought, you just mentioned one thing, right? That a nice team is not always about what they do, but how they do it.
How
right?
they do it.
It brings us to Simon Sinek's, presentations, right? And state talks when Friday says that it's not about what you do, but why and how you do.
Why?
So I think this why is
extremely important.
Extremely important that he important.
Yeah.
That
why is part of the what in a sense, right? What you do, why you'll do that. What's
Okay. So again, about the team composition, right? You talked about this polymath engineering, right? So I think 20-30 years back, right? This concept of polymath engineering was not that predominant, right? And now it has been essential, right? So how do you create a team keeping that in mind?
Yeah. See, I don't think, I actually think there was this concept earlier. If you look at my uncles are engineers and they are very much polymath engineers, they always see the big picture. And then I think somewhere along the line when we started mass producing engineers and building huge teams and, moving, some repetitive jobs and all that, then that got destroyed kind of thing. And I think now we are kind of rediscovering it. If you think of startups actually need you to be a polymath engineer because you have to do it all. You don't have separate people doing RTL and DV and you do it all. So in that sense, I would say the concept always existed. It kind of got drowned or overshadowed by this over specialization that happened, and it hopefully is coming back, right? What was your question? Sorry.
The question was this, that I'm keeping in mind this polymath engineering and its need.
Yeah.
How do you actually create a team around that? Would you look forward to certain skills which you didn't look for in the past?
I think more than skills, I think the inherent things about curiosity is the person curious, is the person taking accountability, not hiding behind. So to me, two things are important in an engineer. One is, of course, inherent curiosity and kind of a scientific temperament where you're trying to understand things fundamentally. And the second is the courage to take on decisions and responsibility, right? You're not hiding behind or pointing fingers, right? I think if you have these two traits, fundamentally, you will do really well in an engineering career. And, Naveen is an example of that, right? I mean, you can see that talent right away, and usually you have an instinct about this person is going to do really well. So that doesn't change, that doesn't change. It's the same as it has always been. Yeah.
Building on that means, I think the question that you asked, right? At one time, we were trying to compartmentalize the whole, the functions. And since with that time, the whole scale was about number of people, that was the as the measure of success.
Yeah.
And in that case, we said that as long as you have the engineering capability to learn and do a problem solving, I'll do that training.
Yes.
Point is, we're moving out from that into saying is that, we will still need saying a lot of those compartmentalized different functions, and we'll do the training and do it. But you still need somebody who comes with a big picture thought process, understand the system's need, be able to do a problem solving in multiple skills. And actually, that's why we see there a lot of shift left that has already happened, right? We are getting some of these into high schools. And then there are BTech programs into VLSI, which was earlier MTech programs. So all of this is the shift left is pushing that mentality of, or the skill, the mindset of having a bigger picture, multiple skills, and coming trained into this, into an organization, and then being part of the any product or the ideation.
That's it. Yeah, absolutely agree.
You mentioned one point, being curious, right? So, one interesting thing, it came to my mind. I recently read Elon Musk, biography by Walter Isaacson.
Yeah, I read that.
So here he has mentioned that, Musk had this tremendous thing about asking why. Anything is to ask why. And by asking why, he landed up, reducing the cost of the rockets by,
orders of magnitude.
Orders of magnitude. So NASA has been doing the same thing again and again for ages, right? And nobody asked. And so he also mentions the same thing, right? Anything and everything, whosoever would have said, ask why.
Yes.
So we have come to the end of this session. So just to add some fire to the entire thing, right? I will be asking 3 rapid fire questions. I will ask one by one, and you have to answer in one word or maximum one sentence, right?
Okay.
So what would be the one myth that you would like to bust about semiconductor industry?
That India only does design. It is moved on into an end-to-end semiconductor development.
The same question to you.
I think there's a myth that you cannot build a technical expertise-based career in India. I would like to bust it. I think we have very good technical experts and excellent career available in India.
Okay. What would be the headlines you would like to see in 2030? 2035?
I would like to see that more than 90% of our internal consumption, the silicon is being produced in India, or the chips are being produced in India. Yeah.
The same question to you.
I would say India being the most trusted semiconductor ecosystem player across the supply chain.
Okay. And the last question, and again, it might offend some of our professors. Which one subject you would like to delete from the course, from the engineering course?
You go first.
I think I would say thermodynamics. For some reason, I used to always fall asleep whenever I read that. Sorry, I never could understand it. Yeah.
For me, the microwave related subjects were tough.
That was number 2 for me. So yeah, good. So thermodynamics and microwave, just remove.
But I would add a lot of, I would say, some of the soft skills into the academia as well. The power of documentation, building the communication skills will be very important in the future work. So I would also say add a couple of those things into the career.
Yeah.
Thank you. Thank you, Sumedha and Naveen, for the insights. I think what we covered in this short session is that we touch base on some of the important things which is relevant to a time when the industry is going through an inflection point, when we are moving from one era to another era. And you talked about the changes which are happening, and more importantly, what the aspiring engineers should look for.
Yes.
And also we spend a lot of time about the elephant in the room, which is AI. I think nowadays everything has AI in it, right? Even any product you buy, it has that AI enabled something, right? So I think we touch base on that. And I think for our listeners, I hope this would be a very informative session.
Okay.
And especially for aspiring engineers who would be joining this industry. And I feel with, I mean, not only AI, but the way semiconductor and electronics have penetrated into our lives, I think, I mean, joining semiconductor would be one way also to help the world evolve better, right? Thank you all. And thank you to our listeners for being with us. Thank you.